We've all been there, right? You're setting up a new display, you're stretching that HDMI cable, and it's like a guitar string. It's so tight.
Oh, absolutely. It's the copper leash, as they call it.
Exactly. Feels so archaic.
It is. Physics is working against you there. An electrical signal over copper well, it degrades really fast. That's
Yeah.
why your standard cable maxes out after just a few feet.
Right. But today, we're doing a deep dive into a device that doesn't just, extend that leash. It basically makes it vanish.
It does. We're looking at the NTI ST-IPFO4K18GB-LC.
That is a bit of a mouthful.
It is, yeah. But what it does is pretty simple in concept. It's a 4K 18 gigabit per second HDMI extender over IP. And the whole game changer here is the medium. We're not pushing electrons anymore. We're shooting photons down fiber optic cables.
Okay, let's talk about distance first, because the numbers here are just wild. I'm seeing 24.8 miles. That's 40 kilometers.
It's a marathon, yeah. And that's if you're using single mode fiber.
Single mode being...
Think of it like a laser, shooting straight down a very narrow glass tunnel. It keeps the signal incredibly pure over these huge distances.
Got it.
If you use multimode fiber, which is a bit different, you get about 1,600 feet. Still impressive, but that nearly 25-mile range, that can change the entire architecture of a campus or a large building.
But I have to be skeptical. I mean, at 25 miles, something has to give, right? We're so used to compression artifacts when video travels that far. Blocky shadows, weird colors. Is this basically a glorified video stream?
No, and that's the key. This is where the specs really matter. This unit pushes uncompressed Ultra-HD 4K at 60 Hz with 4.4.4 color sampling.
Okay, hold on. 4.4.4. That number gets thrown around a lot. Why should our listeners care about that specific spec?
It's everything if you're not just watching a movie. In a film, you can compress the color data and your eye probably won't notice. But if you're displaying, say, computer text or medical imaging...
Right, like an X-ray.
Exactly. That color compression makes fine lines in text look fuzzy and horrible. 4.4.4 means every single pixel gets its own full color data. The spreadsheet at mile 25 looks identical to the one on the source computer.
Okay, that brings me to the other big question.
Yeah.
Latency. The spec sheet boldly claims zero latency.
Mm-hmm.
But physics says light still takes time to travel 40 kilometers.
That is a fair challenge. Zero is, a marketing term, technically.
Uh-huh.
Light takes about 0.13 milliseconds to go that far. But for a human, to our perception, it is effectively instant. There's no processing lag. You could move a mouse 20 miles away and the cursor would move in real time.
So that brings up the over IP part of the name. This isn't just a simple point A to point B extender, is it?
It can be, but its real power is in networking. It uses these 10G SFP slots.
SFP.
Small form factor pluggable. It's a modular port you see in big server rooms.
Yeah.
And because it uses that standard, you can plug this into a 10G network switch.
So you can go from one source to many destinations.
Too many. You can cascade up to 12 switches and add up to 255 separate receivers.
Wow. So you're saying you could have one source in a server room broadcasting that uncompressed 4K video to 255 screens all across a university or an airport.
Precisely. And it's not just video. It carries Dolby True HD, DTS HD master audio, and it has bidirectional IR and RS-232 control, so you can control the source from any of those 255 screens.
Yeah, I did see the price. It's about $970 a unit. So this is clearly not for connecting your laptop to the living room TV.
Definitely not. This is infrastructure. Think medical facilities where the MRI machine is in a shielded room, but the surgeon needs that feed live in the operating room. Or digital signage in a massive stadium. You're paying to completely decouple the hardware from the user.
That decoupling feels like the real insight here. We're so used to our computers needing to be within arm's reach. This suggests that, that physical proximity is becoming irrelevant.
It is. And if you think about the bigger picture, it really starts to change how we define presence. We think of remote as a compromise, a little laggy, a little fuzzy.
Yeah, the Zoom call effect.
Exactly. But if you can transmit uncompressed, zero latency, perfect 4K reality over 25 miles, at what point does that remote presence become indistinguishable from actually being there? If the fidelity is perfect and the delay is gone, does the distance even matter anymore?
That's a line that's getting blurrier every day.
Yeah.
A huge thanks to the NTI sources for all the material for this deep dive.
Absolutely.
And thank you for listening. We'll catch you on the next one.